Hello everyone. Let us begin with rings, fields, integral domains, which is module 4 of your paper Math 2201. Math 2201. I'm just trying a pen paper mode of teaching. I don't know if it will be effective or not. Please give me a feedback whether it is effective or not, because I badly need that feedback. So let us begin with the definition of a binary operation. I have already written it. See that it is an operation from A cross A to A. So you all know that if star is a binary operation defined on A, that means if it is an operation over two elements of A, that will again map to an element of the same set A. So then it is a binary operation. Now let capital R, of course, non-empty set, be a non-empty set, and we define two operations on it as plus and dot. I have kept them within circles to just denote that they are actually just operations. I have not defined them, whether they are addition or multiplication or matrix multiplication or class addition, whatever. So I have not defined what that particular operation is. I have just told that they are binary operations. So I have taken two binary operations over a non-empty set R. If this system satisfies particular some axioms, then they form an algebraic structure called rings. You have already studied groups, so you have ample idea of how to define the axioms. So what will be, or what are rather the axioms? Firstly, R with respect to the first binary operation plus is a commutative group. R with respect to the second binary operation is a semi-group. And the third axiom, they satisfy distributive properties. Or what are distributive properties? That is A dot B plus C equals to A dot B A dot B plus A dot C. This is distributive from the left side. Similarly, distributive from the right side. So B plus C dot A, we can remove the brackets, is equal to B dot A plus C dot A. Okay. So if these two laws hold, then that is distributive property. So actually, basically, A distributes, dot distributes over plus from left side as well as right side. See, this is only one type of distributive law. I have only taught you lattice theory. So there we have seen that distributive, there are two properties, cup and cap. So cup distributes over cap and cap distributes over cup. But here only dot distributes over plus and not the other. That is, plus does not distribute over dot from both sides. Now I come to the definitions of commutative group and semi-group. You already know what is a commutative group and maybe you know what is a semi-group, but let me just give you the ideas. So basically these, if are satisfied, then R plus dot is called a ring. Fine. So if these are satisfied, then R plus dot will be a ring. Fine. Now R plus is a commutative group. What does that signify? What are the axioms? First of all, commutative group. So first of all, I will start with, so now I think I have already discussed in class that for a group telling closure property and just telling that plus is a binary operation is just repeating the same word. So binary operation, what is that? That if you have defined operation over two elements, then that operative resultant is in the same set. So closure property also defines the same thing, that if A and B are in R, then A plus B is in R. So it is actually stating that plus is a binary operation. So I remove closure property from our axiom straight away. So whenever I am telling that plus is a binary operation, need not be told that R plus satisfies closure property. Both are same thing. So I start with associative property. So first is A plus B plus C equal to A plus B plus C for all A, B, C belongs to R. So this means associativity. Next, existence of identity and inverse. You all know that if there exists some element E with the property that any element operated with E gives you back the same element, then E is called the additive identity. Now it is actually called the identity element. I add is additive identity element. Why? Because now I have two binary operations, so I have to be precise about which operation has an identity. So in this case, plus is an identity which is named as additive identity. Inverse, there exists some A prime such that A plus A prime equals to E equals to A prime plus A. So then A prime is called the, I think you can guess it right, that it is the additive inverse and not only inverse, because here you have two operations, so they have to be briefly distinguished as additive and some other. Commutativity. A plus B equal to B plus A for all A belongs to R. So that defines a commutative group. Next, I have also told that R dot is a semigroup. Now what is that? Again, since dot is a binary operation, so I strictly need not mention that dot satisfies closure property. It is implied. So associativity. A dot B dot C equals to A dot B dot C for all A, B, C belongs to R. Associativity. So see. So these are the axioms. So what I have defined earlier, that commutative group, semi-group, distributive property. In the next line, next page, I have just highlighted what is meant by a commutative group, what is meant by a semi-group. So therefore, if all these 5, 6, 7 axioms, I guess 1, 2, 3, 4, 5, 6, 7 for distributive. So 7 axioms. If all these 7 axioms are satisfied, then we call R plus dot as a ring.